Assalamualaikum and hi. In this video, I will talk about histogram. Okay, what's next after we have constructed a frequency distribution? Okay, we can put the information in graphical form by constructing a histogram. A histogram is constructed by drawing a rectangle for each class. The heights of the rectangles are equal to the frequencies or the relative frequencies. Okay, that means on your histogram, you can either use the values of frequency or the relative frequency, and the weights are equal to the class weight. Basically, we are dealing with two axes. The horizontal axis mark the variable, while the vertical axis marks the frequency or relative frequency. Okay, so this is the frequency distribution table from our previous Excel. Okay, as you can see, the frequency of the first class is 9, and then we have 26, 11, 13, 3, 1, and 2. Okay, so as you can see here, the histogram, the first histogram has height 9. Okay, and then we have 26, 11, 13, 3, 1, and 2. Okay, for the relative frequency, this is actually 9/65, and so on. Okay, this is 26/65, and so on. Okay, what about the x-axis? Okay, the x-axis, you can use the limits. Okay, that means the point here is 0, and then this is jadi macam mana? Yes, wait. Macam mana? Tapi dia tak boleh guna ni, dia kena guna dia 0. Kat sini 0.995 kan, atas ni 1.995, sini 0.995, tolak jadi 1 kan. X sama dengan 1 tolak 1 kan. 0,05. Okay, once you have constructed a histogram, you can actually construct a polygon from that histogram. Okay. Um, to draw a polygon, you require the class midpoint. Okay. Then all points are connected with straight lines. We will see in the next slide. Okay, now we have our frequency distribution table, and then from the frequency table we can construct a histogram, and then from the histogram we can construct a polygon. Okay, how do we construct a polygon? We will mark the midpoint for each class. Okay, all the midpoints, and then we will use straight lines to connect all the points. Okay, basically this is the shape of the polygon for this data. Okay, for a very large data set, as the number of classes is increased, the frequency polygon eventually becomes a smooth curve called a frequency distribution curve, or simply a frequency curve. Okay, in the previous slide, we can see that the polygon is quite not smooth, right? Because we are dealing with small data set. But when you are dealing with a very large data set, this will be the shape of your polygon. It will look like it's a curve, not like the crooked line, the one that we have earlier. The purpose of a histogram is to give a visual impression of the shape of a data set. Okay, statisticians have developed terminology to describe some of these commonly observed shapes. Okay, so as you can see here, this is approximately symmetric. Okay, I can draw as if something like this. Okay. Okay, a histogram is symmetric if its right half is a mirror image of its left half. Okay. Okay, this is the half. So whenever you can see the mirror image, you can see this is symmetric. Okay, very few histograms are perfectly symmetric, but many are approximately symmetric. Okay, we are looking for this condition. Okay, maksudnya jarang kita nak jumpa histogram yang betul-betul simetrik, tapi banyak histogram kita boleh katakan sebagai hampir-hampir simetrik. When a histogram is not symmetric, it can be either right skewed or left skewed. Okay, how are you going to recognize which is right skewed or left skewed? Okay, you will look at where the tail ends. Okay, if the tail ends on the right side, then this is right skewed. If the tail ends on the left side, so this is less skewed. Okay, next we have ogive. Actually, there are many ways people say ogive. I don't know, ogive, ogive, whatever. Okay, I will say it simply ogive. Okay, to draw ogive, we need the information of the cumulative frequency. Okay, I have explained on the cumulative frequency in the previous class. Okay, so okay, you can see here it's pronounced ogive, ogive. Well, I will still say ogive. Okay, you can say ogive. Okay, there are two types of ogive. Ogive less than or ogive greater than. Okay, in example 5, let's construct an ogive less than. Okay. Less than. Okay, we will use basically class boundaries. Okay, less than lower class boundary. Okay, when I say class boundary, less than lower class boundary. Okay, so this is less than 134.5 and then 152.5, 170.5, 188.5, 206.5, and finally 224.5. Okay, so for less than, we will need the cumulative frequency for any value that is less than our lower class boundary. Okay, less than 134.5. Okay, less than 134.5 will be anything that is lower than 134.5, and basically that is 0. Okay, 0, because we don't have any frequency that is less than 134.5, because this 10 is meant for 135 onwards. Okay, what about the next lower class boundary? Less than 152.5. Less than 152.5. 152.5 is here. Okay, so this is not yet included, so the value here will be 10. Okay, and then 170.5, less than 170.5. Okay, then we have 12, and then we have 17, and then we have 17 plus 6, 23. Okay, and then we have 23 plus 3, 26. Oh, we need another class boundary, which is 242.5. Okay, 242.5 is here, 242.5. So basically we cover all frequencies, that is 30. Okay, and then when we draw the ogive, okay, once again we will use the class boundary. Here we have, usually we will mark this, okay, to mark the value of the axis. We have some gap here. Okay, so we use this symbol. Okay, the first one is 134.5. So the value here is 0. And then we have 10. Okay, so let's do here 10, 20, and then 30. Okay, the cumulative frequency. Okay, 152 will be 10, and then 12, 17, 20, 23, okay, somewhere here, 26, and finally 30. Okay, when you draw ogive nicely, this is the shape that you should get. Okay, you will start from 0 until 30. Okay, in this case, this is for less than. Okay, for less than, you will start from 0 until 30. If you do more than ogive, you will start from 30 and you will end up with for more than ogive, you will start from 30 here, and then you will go down until 0 on the other side.